Alright guys, welcome back to the channel. I wanted to do a video today answering a question I get from time to time, and I've been doing that a lot lately, answering questions. But this is a question that actually does get asked time to time. To a lot of you, this is going to seem like really simple stuff. But remember, we were all there once. We all got our first machine and didn't know what this was, or didn't know what that was, or didn't know the purpose of this or that. I was asked this question and I was thinking, well, that's a very simple question, but then I thought about how I would have been, several years ago when I didn't know this stuff, and I was asking the same questions. And if you watch a lot of machining videos, and there's a ton of machining videos, and there's a ton of instructional videos on machining, and there's so much out there to watch. And a lot of times the people that are showing you how to do things, they sort of take some things for granted. For instance, the simple drawbar. Well, just about every machining video that deals with a mill, and if they show you their setup, they're going to say something about the drawbar. But what is the drawbar? Is it something special? Is it mystical? Is it magical? Or is it really just a piece of long metal threaded on one end, threaded on the other end, maybe threaded the whole way down? That's all it is. It's very simple. In my case, I made my drawbar from a fireplace poker. Now this is just a M12 bolt. See, it even says M12 on there. M12 bolt welded on to the end of a fireplace poker. Very precision, very precision. On the other side, it actually was threaded on the other side. I extended the threads as long as I needed. I've got a nut and a locking nut, some washers, and then this is just an extension so that when this is down in the machine, I can still access the nuts if I want to. It sticks up above the machine. I'm going to show you that in a minute, what I mean by that. Basically, that's what I want to do in this video, is just go through how these things kind of go together, how they work together. And I'm also going to talk about tangs and why you use tangs instead of your drawbar. A lot of videos just kind of gloss over this sort of thing, but a lot of people just don't know the terminology, or just can't picture exactly what's going on with these parts. And here on the Eddie's channel, I never want to take for granted the intelligence of my viewers, or the ignorance of my viewers. No, I didn't mean it that way. We were all there. We were all at that point where, like I said, we just got our new machine, and let's go through a couple things. So, ER collets. This is an ER collet. This is an ER collet holder. This happens to be an ER 20. All the 20 means is the diameter at the very end of the collet, the overall diameter of the collet. ER 20 collets can come up to, I believe they can actually be an oversize of 9/16. My set goes to a 1/2 inch, down to an 1/8. So basically, the larger the number of the ER system, so this is ER 20, you have ER 36, or ER 32, ER 40. All that means is this collet grows out, gets bigger, and that means that you have more mass holding your end mill, or whatever you put in here. It also means that you can have a larger size. The holders, they're very simple. One thing to note about ER collets, the nut that goes on your collet should snap in and snap out. There is an actual cutout in the collet, in the nut, to let your collet snap in and out. The holders can come in many different sizes. This happens to be a Morse Taper 3 holder, and it has an M12 threaded portion in the end, which allows you to put a drawbar in. And the drawbar draws this tight up into the spindle. Let's take a look at that. Okay, here I have my mill head. I've got it rotated out. I'm going to take the top cover off. You don't necessarily have to do this. There is an access up here, but I'm going to take the top cover off just so it's clear what's going on. So the drawbar or fireplace poker goes down through the top of the spindle. You can then take your ER collet holder, put it up in, and start spinning your drawbar to get it started pretty well. By the way, you should wipe this surface off and the inside surface off first. What then I like to do is just take my hand and go like that. That kind of sets it in place, and then tighten down the drawbar. And that's how it sits. Now, you know, this extension on here is only because when the cover is on, the cover comes up to about right here. So I have full access basically to the nut with that cover on at any position. If for some reason I want to have the quill down and take the tool holder out, I can do that. So then to install the collet, you want to put your collet into the nut first. Make sure it's snapped in. The reason for that is because it has to collapse a little bit to get into the nut, and you will not be able to get your collet into the nut properly if you have your end mill in it. Then put your end mill in after it's already in the nut and just screw it in. And at this point you can lengthen the end mill a little bit if you need to, or tighten it up a little bit. Take your 2 wrenches, tighten that up, and you're ready to go. Now, I said before that my ER collets go up to a 1/2 inch. I think they're 1/8 inch to a 1/2 inch in 16th inch increments. Why did I choose Imperial? Most of my end mills and stuff that I already owned were Imperial, so I got what I knew I could use right away. The most common tapers you're going to see on these little mills are probably MT1, MT2, MT3. You're probably not going to get bigger than that. In my case, my tailstock is MT2, which is this, Morse Taper 2. That's the designation for the amount of taper that is on the shaft that holds the tool into the machine. This is a Morse Taper 3. This is actually a 2 to 3 adapter. I'm not going to take that out. Actually, I can take that out. I'll show you how. Put our little tool in. I'll talk about that in a minute. And you see that inside that adapter is a Morse Taper 2. Now, you'll notice that these tooling holders have chucks on them, and they are tanged. This is the tang here. Notice it will not accept a drawbar. Now, there's a reason that I like using the tanged type for drill chucks. And the reason is because you don't have side forces on a drill chuck. You have straight down forces, which is pushing the taper into the spindle. The tang also goes into a notch into the spindle, which provides a twisting force and does not allow the taper to slip inside your spindle. So the way you remove tanged holders is just like I showed you. This is a tool that I made. It's very simple. It's just a 1/4 inch piece of metal stock. I had seen them when I made one. I had never handled one. I had seen them in pictures. I just kind of guessed the angle. It goes into the slot, and then in this case I can hit it with my hand and it will release. Usually you need to hit these with a dead blow hammer or something to do that. Now, that works in the machine as well. So before we take and put the drill chuck in with its tanged holder, I need to take the drawbar and the ER collet holder out. And the way we do that is just loosen our nut up here. Of course, I would normally use a wrench to do that, but for demonstration purposes I just use that. I usually loosen it about 1 inch, and then I use a pretty solid hammer. This is actually an aluminum headed hammer, so it doesn't damage the threads. Take that and just a nice swift pop. That breaks free your tool, and then you just simply unscrew your tool like so. You can pull the drawbar out if you want. You don't technically have to, but it will rattle in there because it will not be connected to anything, so I like to take it out. Now, to put your tang tool in, if you've never done it before, it might be easier to go ahead and extend your quill. So we got our quill locked down, and you'll notice that there is a hole here. Looking through that hole, if you then rotate the inner spindle by hand, I'm just turning the pulley at the top right here, you should see eventually there'll be a gap in there. That is just like what you were seeing here. So you see our hole through there. We're going to put the tanged tool holder up in, and you should see the tang, there it is, come up through, and you know when the tang is in that position right there and through, so you can see it, it is in the right position to then be hammered home. Now, if it comes to like this and stops, you're not in the right orientation. You need to pivot or rotate until it slots up in there into its slot. So once we know we have it in the right rotation, and you can also tell that because it'll spin the spindle, I'm going to release the spindle, put the tool back in. What I usually do is take the same hammer I used above and just give it a swift knock like that. That's usually enough to get it in there. Once you start drilling, it's just going to get tighter and tighter. Now, you could also take the head of this or any sort of block, come down and against your table and just crank it down. That'll crank it in there. Now that's not coming out. I can physically pull the spindle down. That will not come out. Now remember, with drilling forces, all the forces are directly straight up. So you don't have to worry about your tool walking across a part and wobbling like this. You don't, and that's what will loosen up a taper. That's why you have a drawbar in there. With drilling, it's not an issue because all the forces are directly up. The more you drill, the tighter this taper is going to get. To remove, same way. Put your quill down till you see the hole. Line up the hole inside. Stick your tool in. Hold on to your tool. Hold on to your tool holder or your chuck. Give it a nice, swift, rapid hit. Just like that. You don't have to crank on it, and it comes right out. All you're doing is breaking the mechanical bond between the taper and the spindle. So I hope that was helpful to someone, specifically the person who asked me a couple questions about this area. You know, as I said at the beginning, I know this is very simple stuff for probably 90% of my viewers that like the machining stuff, but remember, we all started there sometime. We all learned what all these things are. What is an ER collet? What is an adapter? What is a Morse taper? Not a single one of us was born with that knowledge. We had to learn it from somewhere and someone. If you enjoyed this kind of video, you know, comment, let me know. I'm trying to get better at my delivery and not just assume that everyone knows exactly what I'm talking about. I think that's really important when you're doing these kind of videos, is that you kind of get in your own mindset and you're thinking at what you know, and you're looking at your machine and you know your machine, but you know a lot of people don't know what you're doing when you flip a switch or do this or do that. And there's a lot of great guys out there that are wonderful at explaining what's going on, and that is great knowledge. Two people that I'll recommend to anyone, and if you're watching my channel and you haven't watched their channels yet, well, I don't know what's wrong with you, but I'll put a couple in the description. Let's just do it that way. because I can't remember them all right now. Mr. Pete is the big one. He does a lot of machining 101 type videos. But like I say, if you enjoy this type of video, please let me know. Send me a comment, give me a thumbs up, and you know, I'll do more in the future. And if you have any questions, I'm always open to answering questions to the best of my ability. I'm no expert, but you know, I play one on YouTube. And we'll see you next time. Thanks. Bye.